tomorrow. There are pretty much 3 key ideas. You need to know vertex, form. That's what I said, you may need to do or use the back of your paper. And standard form. So vertex form is y equals ax minus h squared plus k. Standard form is y equals ax squared plus bx plus c. So vertex form tells you exactly that. It shows you the vertex. Standard form is the more popular form that we worked on and focused on throughout the course of our study. You will have to know how to graph from both forms. You will have to know how to graph from both forms. Oh, I had you two outside. The vertex in vertex form is the opposite of what it is in the problem, comma k. In standard form, you must apply your formula to find the vertex. If you go back to the example on the front, I have given you a graph of a quadratic. So what we're going to do is use that graph to determine some key pieces of information. The domain of all quadratics is always all reals. The domain of all quadratics is always all reals. The range will deal with the graph and if you have a max or a min. So this graph is open up. This graph, because it is open up, has a low point. That low point is known as a minimum. That low point is known as a minimum. The minimum is also my vertex. The minimum is also my vertex. So where is that point at? Well, that point is at 2, -4. So my vertex is at 2, -4. And I know that's your next line, I just can't see mine, right? So your vertex is at 2, -4. The minimum is the y value of the vertex. So in this case, it says, what is the minimum value? The minimum value is -4. The axis of symmetry is the x-coordinate of the minimum. It is an x equals equation. The range is the y value and up or down. So in this case, the y values are going up, therefore greater than or equal to -4. The x-intercepts are another way of saying the zeros. X-intercepts are given as ordered pairs. X-intercepts are given as ordered pairs. These occur when y is 0. you can see them in this case on your graph. They are at -2 and 6. If I asked you to describe these not as the x-intercepts, but as the roots, then you list them as x equals. So I ask you for roots, you tell me x equals -2, x equals 6. That's the difference. Zeros, x-intercepts are ordered pairs. Roots are x equals. The y-intercept is the point when it crosses the y-axis. The y-intercept in this case is 0, -3. Now, I may give you a question on your test that doesn't necessarily have a graph, but gives you 2 points. So it may say your vertex is -2, or +2, sorry, -4, and a point on your graph. Now let's use a not nice point just so we get like kind of messier numbers. A point on your graph is 4, -3. I want you to write the equation in vertex form. So you had a couple of B's on Friday's review. It gave you a vertex, and it gave you a point, and it said, okay, what's the equation of that line in vertex form? So what you're going to do is take that vertex form that we already talked about and plug in 2 for H, -4 for K, +4 for X, and -3 for Y. So we end up with Y equals A, which is what we're looking for. It's what we don't know. We know H, we know X, we know Y, we know K. X is 4 minus, again, my H value is +2, squared plus K. Solve for A. We get 1/4. So what that means is that this graph is compressed. So instead of going up 1 and right 1, it's going up 1 and out 4. Right?
Is that how lines supposed to be done?
This?
No, on 4A.
Yeah, it's like crossing them out.
Oh.
4A divided by 4 is 1. So your equation for this graph would be y equals 1/4 x minus 2 squared plus k. That's sort of everything in a nutshell. The alternative, or the other things that we didn't look at, would be how do you graph on your own. So if you take out Friday's assignment, does anybody need 13 or 14? I can do either one. So it looks like this. So that's in standard form. So if it's in standard form, I need to identify my vertex. To get the vertex, I need to get the AOS. The AOS is equal to that x equals negative b divided by 2a. In this case, my a is -1, my b is -1, and my c is +1. So my AOS, which is my h, would be negative a -1 over 2 times -1. Two negatives would make a +1 on top over -2. That means my vertex is shifted a half a unit to the left. My k value takes that vertex point and plugs it in. So you have 1.5 minus 0.25 or 1.25. No. Correct. I will not. Like you might have fractions in a table, but not to graph. No graphing will involve a fraction. It's just too hard to grade. So what happens here is we end up with a vertex that looks like this. So again, if you go back to that same concept or that same problem we just did, if you were to write this in vertex form, y equals -1 x plus 1/2 squared plus 5/4 would be my vertex form equation. I would then make a table. And again, the table for this is going to be a little worse because fractions. So we have our vertex, we have our AOS. The last thing on here it asks for is y-intercept. The y-intercept in standard form is always the c value. So that means this point also goes through 0, 1. So in the standard form, the y-intercept is always the c value. My table is always, I'll pull a graph on that. You're always going to manipulate or apply that rule, where everything up on the whiteboard in purple doesn't change and everything in blue doesn't change. What changes is the points that we graph. So in the last problem, the h value was -0.5. So all my x's are moving a half a unit to the left. So -0.5, 0.5, 1.5, and 2.5. My y's are all reflected because a was -1. That tells me that this graph opens down like a frown. It tells me that I have a max. Then what we do is we multiply by a and then add or subtract, add or subtract my k. So in the last problem, k was plus 5/4. So we're going to add 5/4 or 1.25 to each of those problems. So you start at 1.25 here. 1.25 minus 1 is 0.25. 1.25 minus 4 is -3.25. And then 1.25 minus 9 is roots go between a positive and a negative. So again, taking into account roots, if you look at this table, positive y, negative y. That means that there is a root between 1 and 2. So if I had you graphing and telling you where the roots were, but they're not perfect numbers, you would have to be able to pull it from here or from the graph. Pull up a graph. So plot -0.5, 1.25. Now I'm going to go by the same scale you have, which is
ones.
Plot 0, 1, because we know that's my y-intercept from up above. Plot 0.5, 0.25. (1.5) negative 3.75, and then 2.5 negative 8.75. The points are symmetric, right? So if this goes negative 0.5 to 0.5, that's 1 to the right. This just goes down 1 and 1 to the left. Down, over, down, over. Once again, roots come from this line. So looking really closely, your roots are between, and I picked this one, kind of because I want you to see in that table too. If you made the table, you look for the change from positive to negative, and then it's your x values. So between x equals a half and x equals 1.5. On the left side, it's going to be between negative 1 and negative 2. And again, if you pulled it from here, you could have also, instead of like a half and 1.5, you could have said 0 and 1, because you can see that from your graph. There will be fractions on your graphs or tables, so they'll be easy to see. The numbers will be